So yeah, good morning, good afternoon, good evening, wherever in the world you are. My name's Nick Davey. I'm a director of product management, and I'm here to talk to you a little bit about how we can build all of these things that my colleagues just told you about. Because like you heard from Praful and Mansur, the workloads, the applications, the use cases that we're trying to drive out of modern data centers are pushing scale to ridiculous levels. When you look at those designs on the previous presenter slides, you'll see complexity and you'll see connectivity like we've never had to provision before in data centers. And as a former network engineer, I do not want to be doing any of this by hand. So I'm here to talk to you today about how you can build all of this and not be overly bothered with the details. Of course, our answer for this is taking all of that science, all of that research that we've come up with in our labs, all of the testing and qualification that we do around our products and our use cases, and we pack those into a set of validated designs. The JVD I'll be talking about this morning is our AI JVD, which talks about how to build a ready-made AI data center. In addition to the types of things you'd normally expect in a design white paper, right? Things like architectural diagrams and configuration, protocol explanations, and a little bit of chitter-chatter about the encapsulations, we actually include one more important thing, and that's the automation actually required to make these things spring out of the box and come to life. That was a question earlier, I think, about like how do we actually package a JVD and what do you get, right? You don't just download a PDF. I'll show you later, and Raj will actually show you for real, how we take automation that we design around our JVDs and instantiate real data centers using the power of Abstra. We try and bake in all of the learning that we do in our labs into these JVDs. Actually, we posted the AI JVD this morning. I think if you go to juniper.net, you'll see that updated document. And so we try to keep these things up to date and packed full of our latest guidance on how to deploy the most complex networks. Of course, even for AI, there's no one size fits all, right? And so part of the automation that we build actually lets us t-shirt size these things appropriately to your use case. We'll talk in practical terms about where that can be handy, like when we're sharing a big AI lab that we all want for our very own. But one of the practical things we talked about this morning was oversubscription ratios, right? Or even the dimensions or the physical hardware making up one of these AI data centers. All of that gets packed in as parameters into our automation so that you can tweak and tune your AI JVD to match your network's requirement. Central to all of this is Abstra. And there's a very good reason for that as well, right? Because like when Mansur said that folks are bringing back workloads from the public cloud and starting to reestablish large private cloud data centers, the one thing that he forgot to mention, it's very important that people brought back from the public cloud, it's expectations. People are very used to, and operators, application owners are very used to clicking a button and receiving the thing that they asked for. They don't go into a protracted set of meetings. We don't open tickets. We don't have discussions about it. We press a button, and sometimes we slide our credit card, but usually we just get the thing that we wanted. So that's the experience that we have to beat. And I'm happy to say that all of the technologies that make that experience possible in the public cloud are possible in your own on-prem DCs as well. Abstra gives you that central point to control an entire data center. So you can look at that as offering up a cloud-like API to consume physical data center resources. I actually stole this analogy from Raj, and he'll talk about it more later. But I love it so much, I'm front-loading it here. Because the Abstra design cycle kind of mimics the things that we've been doing in network engineering for years, right? When we're standing up a new data center, we design it first, and that normally takes place, oh my gosh, we found a room without whiteboards. Okay, this is perfect for what I'm about to say, because we've moved the design off of the whiteboard and into the orchestrators and automation tools. So now instead of drawing stuff up with markers and getting your hands dirty, you can actually design and pre-stage the network you're going to build. After our designing and planning phase, and this as well is where we populate all the attributes and assets that we need to design a data center, like ASNs and VLANs and IP addresses, all of that goes into our design phase, so it's more real than you would ever have in your Visio or your whiteboard designs. Once you've got the mock-up, the design in a state that you're happy with, you can go ahead and assign physical resources to that design. And that's the first time that you ever have to tell Abstra about hardware. So you can do all of this work in the abstract and then start picking the physical devices that you're going to plug into each one of these roles. They can be Juniper QFXs, or they could be any of the other vendors that we support. This is the time where Abstra decides kind of what config it's going to cook when it instantiates that network. And then finally, once we've got our design locked in, once we've got all of our physical hardware kind of chalked into its spots, then we can actually deploy the network. And we use ZTP to take a pile of brand new switches and bring them up into the configured fabric design that you've specified in that day zero section. Finally, there's the long tail of these things, right? Because designing and building is kind of the big monumentous event. It's kind of like a celebration. We smash a bottle of champagne over our new data center. And then we go ahead and do the day-to-day work that carries on for years on end. And so we'll finish up today's session talking about how we embed a whole bunch of probes and monitoring tools into the deployed networks to make sure that they're always running in the state that we wanted them to be in. Now, why is this critically important to AI? I mean, you could convince me that it's no fun to configure a Clo fabric by hand. But in AI, when we talk about the scale of deployments that we need, in terms of both complexity of the fabrics, the number of fabrics, as well as the demands of the workloads, this is not something we want to do by hand. And we want to benefit from all of the research and the lessons that have been learned from our labs, from our partners' labs. And so this is where the AI JVD takes all of those concepts of Abstra and bakes those into an AI-specific incarnation of these deployments. We do that, for example, by embedding those rail-based designs that Praful talked about into our reference architectures. So you don't have to figure this stuff out by hand anymore. It's already baked into the blueprints. You load the JVD into your Abstra, and then you can start from that foundation and tweak and tune it to match what you want it to be. The deployments, well, again, we're pre-staging all of the configuration for a typical EVPN data center, but we're mixing in all the sugar and spice required to make it an AI or a data center that can carry AI workloads. And that means things like that DCQCN configuration and all of the sort of the sets of configuration that make a fabric reliable enough to run an AI workload. That gets baked into the design as deployed. And then finally, we've built a set of probes and optimizations that monitor all of the various queues and flows in a network and can optionally tune that network based on its observed values. And
you see this as happening for like the front-end network and the storage back-end network and the GPU back-end network as separate, distinct entities? Are they all kind of wrapped into one deployment, or how does this play out?
So we give it to you as one big omnibus, and then you can break that apart and pick which parts you're going to deploy. So Raj will show you when we spin up the AI JVD, you end up with the front end, back end, and storage designs, like blueprints within Abstra. Those are 3 separate fabrics that you're deploying. They could be on 3 separate independent pools of hardware. And you can decide and deploy decide how you want to deploy those independently. So it's not like a one-shot deal. You pre-stage all 3 of them, or as many as you need, and then you can decide how you want to deploy those.
The Terraform that we provide is basically like a starting point. You can take that and, like every other project I've worked on, you take code that's already working and hack it to, suit your needs, right? So we provide the Terraform that gives you like a baseline that you can start with, and then what you do from there is entirely up to you. I mean, it's your hardware.
And the Terraform is something you would store into GitOps or GitHub or something like that, so you can monitor its configuration changes and things like that.
Yeah, 100%. Yeah. So the demo the demo that I'll be showing uses GitHub. There are other videos we have online where like we used GitHub and Terraform Cloud and the integration they already have there. So you can actually create a pull request to your changes, have somebody approve it, and on approval,
is Abstra creating the Terraform, or is the Terraform somehow being fed into Abstra? Yeah. I mean, how are they interrelated?
So we are creating the Terraform, and that's we've created an Apstra Terraform Provider to expose all of the first-class objects within Abstra to Terraform, and then we consume those resources via a set of projects that we make for each of those networks, and then we publish those to GitHub. So, sorry.
Yeah, I was going to say like the whole intent-based approach of Abstra ties in very nicely with the declarative approach of Terraform, right? So like it's a nice match because it's not like Chris Marget, the other guy who wrote the code. Some of you know him. like he says, it's verbs, sorry, it's nouns, not verbs, right? So it fits very nicely with the fact that in Abstra, you express an intent and you expect Abstra to take care of it. So we wrote the Terraform provider to match Abstra objects. So this happens, and the network does its thing.
Yeah, absolutely.
I hope that answers your question.
Well, there's a tiny bit more unpacking I want to do on that as well. Because there's a great set of screenshots here that kind of prove my point. Operating these types of networks by hand is not a lot of fun. I love having these types of designs because it's great. I hate drawing network diagrams, and it's great to visualize kind of an as-built or visualize a topology. It's really easy to explore a design and kind of at a glance figure out what's going on. But if you needed to change anything in here, or maybe make a bulk change to what's going on in your deployed AI data center, it would be just monstrous to have to click through and to manually make this change, even with a tool like Abstra. And so we view Terraform as kind of the power tool that connects to the power tool, the universal remote, if you will. Its job is to let us do bulk operations, to work at AI DC scale with these automation tools. And again, it's with the happy coincidence of meeting that expectation of our cloud users. They want to automate their infrastructure without waiting for us to do our job. This is the way that we can expose those interfaces in a safe fashion as well. So yeah, I mean, not just for buzzword bingo purposes, but yes, we benefit greatly from having configuration represented as plain text, by having the ability to check that into version control, and then to perform testing and validation around this as well, right? Ultimately, we are running a lab, so if we need to throw this at a test cluster and spin something up quickly, it gives us that dynamicism. And yeah, sorry, I think we kind of talked around this as well, but the AI JVDs, this is actually a screenshot of what we get when we deploy the AI JVD right off the bat in Abstra. The neat thing about, like I said, whiteboards, you can draw on them regardless of what you have, right? There's no, you don't need to physically have the thing that you're drawing. Same thing with Abstra. You can do the design phase. You can load all of this into an Abstra instance and see what the network's going to look like, model it, tweak it. Until you click build, it doesn't assume that you have hardware. So there's some neat stuff you can do when you talk about, I think there was a question earlier about kind of building a digital twin of your infrastructure, trialing changes before you take them into production. Yeah, you can stage it in Abstra. You could also point your Abstra at a whole pile of virtual switches and run it for real. So there's a whole bunch of really neat stuff you can do once you have these tools.
And are you able to overlay this? Say I have my digital twin of the existing data center, and I want to deploy this as a new section of that, but utilize the existing software. I'm able to try to perform that merger in my digital twin.
It's not a first-class object in Abstra, so you can absolutely do that by having a set of switches or a set of hardware that are virtual Junos or virtual Junos Evo or any vendor's virtual switch, right? So you can add that digital twin. If I'm understanding your question right, you could add a digital twin.
Well, I have a digital
something in
twin
virtual.
of my existing data center, and
Yeah.
I'm going to add an AI cluster to this and connect it to the existing and utilize the existing infrastructure hardware.
Yeah, you can absolutely do that. There's no first class objects to do that. So we don't make any distinction between virtual switches and physical ones. You can absolutely plug them together.
Right.
Where does security fit into all this stuff?
I mean, it's kind of a part of everything, right? So as we're exposing APIs, that puts an incredible burden on securing the API surface. Thankfully, we wrap things up in TLS and do cert checking. I mean, the keys to Abstra become very, very important. They're now your API bearer tokens. So kind of if anything, the thing that I like about having a tool like Terraform and wrapping up your workflows in GitOps or something similar is you can bake in checks, balances, and controls. So say sign-offs on check-ins, right? You can have a change reviewed to your Terraform project before it's pushed live. That gives you mechanisms to control or to add more constraint to a deployment. It's not necessarily infrastructure security, but it's assurance and resilience for your network. We're going to talk a little bit about, and I think I talked about this a little, right? Like why we build tools on top of Abstra, right? It's to give folks that power tool to do kind of more than you would ever want to manually provision. It's also to meet the expectations of those folks coming back from the public cloud, right? We need to offer that I can't believe it's not AWS type experience. There is actually something else we get when we start wrapping tools around Abstra, is we can make those tools talk to each other as well. And that's what we're going to show you a little bit about today. Yeah, sure, we've created our Terraform Provider, published that up on the internet for you all to try, and you can all build your own automation around this, but that's still kind of an expert level tool. So how do we build tools on top of the tools? And this is where we'll show you, and Raj has done a great job building out some integration into ServiceNow, so we can show you the ultimate in kind of consumable interface, where you can order up your infrastructure just the same way you would order any other IT service. And I mean, it feels strange, but when we talk about sharing a constrained resource like an AI lab full of GPUs, there's a lot of people waiting in line to try stuff. Having something like a ticketing system wrapped around this so someone can say, you know, I get next, or put their coin on the jukebox, or take their ticket out of the ticket dispenser, whatever your favorite analogy is. This gives them a mechanism to command the infrastructure via that high-level interface. What we're specifically going to show you is how we share better at Juniper, specifically how we share our AI lab better. So we have built a set of Terraform projects that based on our AI JVD that match the typical topologies that we deploy in our lab. Different oversubscription ratios, different configurations, and also we have the ability to slice our cluster smaller if needed to share amongst the folks who want to use it. We've gone ahead and built a ServiceNow workflow on top of this to create these kind of first-class objects in ServiceNow for the various data centers that we're going to deploy. And so when a user kicks off a ServiceNow request, it'll call a set of Terraform projects that'll reach out to Abstra and instantiate the type of network that that user has requested.
And does that plug into the Slurm orchestration for the actual work that runs across that network, or how does that work?
So we didn't do it for today, but you absolutely can, and that's the funky thing about Terraform. Terraform being multi-resource automation toolkit, you can throw in the automation to stand up the servers. So we could say pixie boot a handful of servers, install Kubernetes or install Slurm, whatever the application is on top of that. And that's kind of what we're envisioning. Like if an organization, or actually if this is what we need to do for the lab, we need to add on that step where we actually bring up the server infrastructure. Right now we're sharing kind of a pre-built cluster and just changing the network subscription ratios and queuing parameters around it. But as we take this, as we make this more advanced, we'll need to actually slice out the hardware and maybe make a new small cluster for like Raj and I to play with over the weekend or whatever we need, right? Sharing is caring. And again, all of this stacks up on everything you've heard today, right? So we're going to be deploying, and hopefully what you see is everything gets realer and realer, leaping off of the slides, and we'll show you how it can jump right onto your Abstra instance running in the cloud or on your laptop, wherever it's running. But we'll show you how we deploy all of those networks, and hopefully you get a sense of how we coordinate like front end, back end, and storage, what parameters we expose to let you tweak those and modify them. Like I mentioned, we have tried to publish everything on GitHub. So our Terraform Provider is up on GitHub. The AI cluster designs and all of the automation for the newly published AI JVD are also online. And I do not expect you to copy those links. So here's some QR codes, and I promise they are what I said they were. There's nothing hiding in these QR codes. They're just GitHub links. It's the easiest way to make an entire room of people nervous. So yeah, we've up there published the AI JVDs, and we have the cluster designs themselves. So you can go ahead and see the kind of what we've built, why we've built it, and then the Terraform projects to instantiate it. Like I mentioned, you don't need hardware to do this. You can throw this at your own Abstra instance. So if you just wanted to poke around and see what we've done, you can go ahead and do that. And if you just want to see what types of automation we're building around Abstra, you can check out these two repos as well. It's got the actual Terraform Provider itself, so all of that development is done in open source, and it's published up on GitHub. And then we also, because I think the foundation of every network automation project always starts with copy and paste, right? I can't be the only one. So we have published a set of examples that you too can copy and paste from, including everything we're going to show you today. So if you want to see kind of how real this stuff is, or kind of what we think is important to expose out of Abstra, take a look. You can try it for yourself. But yeah, I've made enough bold claims now. So now I'm going to pass the mic over to Raj, and he can show you how all of this actually works.
All right. Hey, folks. I'm Raj. I work on the automation team. We are responsible for a bunch of automation. Mostly in the past 2 years, I've been here mostly focusing on Abstra one way or the other. So I think I mentioned Chris before. So Chris Marget, Bill Wester, and I have been focusing on the Terraform Provider for Abstra. The whole vision of this is that you should be able to manage your data center just like you manage everything else. General idea is like you want to deploy an application, you create the Terraform, like the application guys have Terraform for their application. The idea is like if you could have your network changes also as part of the same Terraform configs, you can deploy the whole thing in one shot and everyone's happy and nobody gets woken up at night. So that's the goal here. Like everybody else mentioned, like I said, like this whole thing builds on previous things. Like everybody else here mentioned, right? Like Abstra makes it possible with its API and the provider that builds off of the API to basically automate your data center. So what we see here is ServiceNow on the left, Terraform Cloud in the middle, and an empty Abstra on the right. Right. By the way, that is a Cloud Labs instance. If you want to try out Abstra, I highly recommend Cloud Labs. As a developer, I don't know what I would do without Cloud Labs, right? You can bring up your instance. There are a few, there are a few kinds of instances around, and it's great for just developing code.
And it's Abstra Cloud Labs for those of you furiously Googling right now.
Yeah, it's cloudlabs.abstra.com. You'll get there. I think it's running at 2 times the speed, which is, I think, appropriate. I don't really type that fast. So we wrote some custom automation in ServiceNow that talks to Terraform Cloud. And Terraform Cloud is effectively our sits in the middle, and it automates that Abstra out there. It's going to basically build out the 3 fabrics that are in the AI JVD. And it's just going to go, right? Yeah, in real time, this takes 5 minutes, okay? And I'm running it at have double speed, so it's going to take 2 minutes. Everything that's here, except for the ServiceNow stuff, which I've not yet put on GitHub, everything else here is on GitHub. So while that's running, it's running. It's going to take another minute.
Somewhere you mentioned Abstra, AI extensions for Abstra. What sort of AI extensions are there for Abstra?
We are in the process of developing those. Basically, what we're going to show later today, we are going to be doing some. We have some closed loop automation that we are working on, so that's part of it. Jay is going to show you some custom collectors we have created to pull custom telemetry that are pertinent to AI in Abstra. And then the demo later today will basically put the whole thing together to do some tuning for Abstra. To tune the fabric using Abstra for AI applications, not for Abstra. So there are 310 objects. This is going to go, and it's going to create your AI cluster. It's going to deploy the AI fabrics into Abstra for you. Just like in the cooking shows, I have the completed dish out here because nobody wants to watch something boiling for an hour. So
and we are in the Julia Child's meeting room.
Yeah.
So it's just perfect.
That's
I couldn't resist.
That's perfect. I didn't think of it. I'm slipping. So so you go in here you have your it basically shows you the fabric. this is basically what our lab looks like, except, this is a virtual instance. This does not have like devices backing it, but this is what our lab looks like, right? And I want to call back to what Nick said before. This has taken you all the way to the point where you order your gear, you rack it up, and you actually have to do it, right? So this would have started life in a normal environment on somebody's blackboard, and then onto a Visio document. Everybody approves it, everyone's happy, and then like you buy stuff, you rack it up, you do all of that. This has basically done all of that for you, right? The only thing remaining is to buy really expensive gear and make it happen.
Get as many
right?
GPUs as you can.
Yeah.
Plug them in. Yeah.
Yeah. Incidentally, like the Terraform for the AI JVD, if you give it a list of device list of device IDs, will also take care of deploying the devices. It'll take care of deploying the devices. So all this happened, basically because of what Abstra enables, right? Is it possible to do all of this without Abstra? Yes, but it's going to be really, really complicated, right? The marriage of intent-based networking and the declarative nature of Terraform really lets us do this in very, very short, very, very short order, right? The idea is to take this automation and hand it to the end user, right? Because ultimately, the person who kicked off that ServiceNow request will not be a networking person and should not be either, right? Like it's going to be the data scientist, somebody who wants an environment to play with. They do it. Nobody calls us. And it just happens, right?
And if you're hearing a note of selfishness in all of this, it's because Praful just invited the world to come to our AI data center, and we need to be able to spin around a different design and a different deployment for every customer who walks through the door.
Right. And I don't want to be the one doing it. I'd much rather write the code, put it up on GitHub, and let people have fun.
Yeah.
Right. And like the code's right here. Let me show you like something I did just a few minutes ago. If I can figure out how to. So here is the. There you go.
Your tab is hidden.
Yeah. So this is a change that I pushed out just an hour ago while sitting here. Basically, all I did was, change the name of this blueprint to say like backend GPU fabric for CFD, right? I did that simply by pulling down the Terraform, changing the name here, and then pushing it to Git.
And we wanted to show you a really good example as well as how we've put parameters in the AI JVDs to help you control it. So, I mean, it's not just things like the names, it'll be over subscription ratios, it'll be hardware platforms. It's all of the details that you would need to change as you're deploying your data center.
Right, like, you want to partition your environment, you want to create like a new virtual network with just for like 2 or 3 devices and hand that out to somebody. There is Terraform for that, right? And you could tie this with an actual application deployment like Slurm or something, and the whole thing would be taken care of like in one Terraform apply. That's the vision here. I think I've said everything I wanted to say. Any questions?
So you see ServiceNow as an alternative to Terraform?
No.
As a front end, so that folks like once we're always thinking about what
so
tool are we going to so what tool do we want to hand up to the layer above us? So from the network we wanted an API, we got Abstra. From Abstra we wanted a text-based automation tool, so we have Terraform now. And I can write Terraform as a recovering network engineer, so it's a great high-level interface. But for the folks who need to go one step higher, we need a button. And ServiceNow is the button that everyone expects to provision their company's infrastructure. So we put the Make the AI DC Go button in ServiceNow. The cool thing about Terraform and Terraform Cloud is you can put that button anywhere. So we have customers building this into CI/CD pipelines. We have folks using ServiceNow. We have folks building their own custom dashboards.
Yeah, if you look at like, we have other examples. Like there's another example where we integrated GitHub and Terraform Cloud so that it makes it look like basically just like how a software engineer, creates a pull request and it gets deployed all the way to production. Did the same thing with Terraform and GitHub and Abstra, right? So you basically express your network change as a pull request, right? And I'm not even a recovering network engineer. I was a programmer, right? I've always doing like network adjacent, like the last job I did, like we were automating like a private cloud. So I wrote the code. I would work regularly with the networking guys. So it makes it, even I can understand this, right? So that's kind of the power of this whole infrastructure, this whole ecosystem, right? And the idea is like the next level is like is an end user who really doesn't care about networking or about devices or about any of these things. All they want is like to log into their Slurm, right?
Make
So
my application
yeah,
work.
exactly. So just go into ServiceNow, ask for what you want, and your company gives you your Slurm.
One, ServiceNow enables all of their integrations as well. A Slack bot that says, "Hey, I'm a researcher and I want this," and
Right.
it goes up to ServiceNow. It goes over to Abstra, and everything kind of gets deployed the way that they want it, and they have no idea what's on the back end.
Yeah. And like by magic, the leg bone connects to the hip bone and everything dances, right? And that's what we're aiming for. So we actually have some practical examples that Jay's going to walk us through, and we can show you a live network where we've built and deployed all this and how we monitor it and kind of what some of this custom AI work that we've done is. So maybe the best way to show how this all works is to show you.
Well, just one other high level thing first. This is obviously going to work really smoothly in a deployed data center where I'm laying things over top of the existing Clos architecture. But you're also running a lab here. So there's going to be times when you're deploying a lab that's going to require recabling of things because of the new application that's being deployed. So what happens on the physical end to assist the physical end when the architecture I want to deploy has to be cabled differently than what's out there now? And will it detect that? How does it help me get the cables moved?
Yeah, so on the network side, it's using LLDP to map out where things are, and Abstra will detect any deviation from its set topology as what it calls an anomaly. So it'll say that I have a link anomaly. I'm not getting the LLDP, or I'm not seeing the LLDP neighbor that I should be seeing on that link. The other thing that Abstra will do is print out cable maps of a topology. So you can say, where should all this stuff plug in? And it's meant to be handed to a data center technician or someone who's going to go plug it in, usually me. So yeah, that's kind of on the logical side.
Highlight the changes then. So I've deployed architecture. I have A deployed. I need to deploy B that's going to require 6 cable swaps that my field tech has to ride out to the dark data center and do.
I haven't seen a diff. I may have to look into that for you.
Feature request.
Yeah, I heard that, but I really do like that.
So are we going to see a demo today of, say, a failed network configuration? And are we going to see any other types? Are we going to see specific examples of a model, an AI model being run either in learning mode or in fine-tuning mode?
Jay's going to show you a whole range of anomalies. We've got like a very network focus here, so we'll show you what congestion looks like or what packet loss looks like.
Excellent.
But Jay will walk you through some live scenarios, and then we can torment Jay once he's up here and make him show us whatever we want.